So what is a BeaconFence? BeaconFence is a new developer proximity solution. It gives you GPS-free indoor and outdoor location tracking and events that take place as the user of the smartphone application moves inside of an area or inside of a zone. BeaconFence has a mapping technology that allows you to define rectangular and radial zones for any physical layout. The mapping tool allows you to visually draw layout of physical locations and beacon placements. With that information, you can track the location down to inches or centimeters. You can track the intersections when a user of a smart device enters or exits. You can have callback events that take place. You can tie that into your enterprise infrastructure. BeaconFence-based applications will run on iOS, Android, and OS X today. And in the future, as Microsoft delivers beacon-based technologies in releases of Windows 10, we'll be able to add the same technology. Now, compared to geofencing, BeaconFence-based applications are designed for environments where distance accuracy is very important. And you can try BeaconFence today for free. All you need is to be a current RAD Studio Update subscription customer. Then from inside of the ID, you can launch the Get It Package Manager. You can click on the install. It'll download the package files, the library files, the header files, the interface units, even a sample application. The license allows you to build a BeaconFence application made up of up to 3 beacons for a specific location that's no more than 1,500 square feet or 150 square meters. And you can build one application with the Pluto license and deploy it to your users. If you want to upgrade your plan for larger BeaconFence-based applications and larger numbers of beacons, contact our Embarcadero sales office or reselling partners to upgrade your plan. So let's take a look at a demonstration of using BeaconFence in action. We'll design an office layout, we'll place the beacons, and then build an application using the map information, using the zones and the path information that you design in the map tool. As a reminder of doing proximity-based application development using beacons, we've got a simple sample that ships with XE8. It's the beacon component example. It's got a T-beacon component, which allows you to watch monitorized beacons. You set that property to a collection of beacons. In my case, I've just got one beacon here with its UUID and major and minor value of 1 and 1. And then 2 events on beacon enter, on beacon exit. I've got a button here just to enable the beacon and disable the beacon and to clear out the memo lines. Those event handlers for the beacon on beacon enter. It displays the UUID, the major minor number, and the distance. And when it exits, it just lets me know that a specific beacon with UUID major and minor value has disappeared, and we display the current beacon count of the number of beacons that we found. So let's go and run this application on our iOS device, in my case, my iPhone 6. First, the app starts and it says, allow the beacon component to access your location while you use the app, and I'll say yes, we'll allow that. And then let's go and click the start button, and it finds the new beacon. This is my beacon here. It's about half a meter away, a little less maybe. So I just connected the beacon. In this case, it was a RAD beacon from Radius Networks. So I unplugged it from the power source and then replugged it back in and got the beacon showing up again. To build BeaconFence-based applications, you need to make sure that you've purchased at least the free Pluto level of license, and then you can upgrade from there by contacting our offices and reselling partners. Under Tools, Get It Package Manager, you'll see that I've already purchased BeaconFence 1.0, and I've installed it into my RAD Studio XE8 Subscription Update 1 IDE. So we'll create a new project, and now we have a choice of 2 different components that come with BeaconFence. One is a beacon zone fencing component. The other is the beacon map fencing component. So let's look at beacon zone component first. Add a beacon zone fencing component. You can set a base beacon UUID if you want. There are options for beacon manager, the same properties you saw using the T-beacon component of scanning time, sleeping time, and so on. For zones, you can create zones using the zone item editor. And here you can specify beacons that make up that zone, their UUID, their major and minor values. You can also decide whether they'll do something when your proximity is near, immediate, far, or when someone moves out of range. Beacon zone fencing allows you to define zones based on beacons without using a map. You can also use the beacon map fencing component. You can use both zone-based fencing and map-based fencing in the same app. So if we go to beacon map fencing, you'll see it's got the beacon manager options again at the top level. We also need to set a paint control where we want to display the map. So for example, if we want to guide a customer through a department store and show them where they are on the map, then you would use the map fencing for that. We might, for example, put a panel down on our user interface and add a toolbar and other things. Then we would tell map to paint on the panel. Right mouse click to say edit fencing map. You can clear the map. You can save the map to an external XML file. You can also load an existing map that you have from a file. We'll right mouse click and say edit the fencing map. We'll create a new map object. We can specify its fill color. First thing we'll want to do is set measured units, for example, inches, meters, or centimeters for the map. Let's add a bitmap. I've got the Scotts Valley office floor here. It's important to use the option to scale the map property, and again, we recommend that you do that before you add any other objects. That way you can provide the physical measures on the map for the image that we've just selected. So we just need to click 2 points on the image and indicate the distance between them. So for example, on our office map, click Scale the Map tool. Let's go and drag the distance here across here, which is 25 feet. So let's go measure this opening, and we need to set the distance in inches. Well, that's 25 feet. So 25 feet is 300 inches. So now we've defined the scale. And just a reminder, if you delete the map, you lose all of the parts that are there. So we can go and save this map file name. So this is Scotts Valley. All the information is saved in an XML file. Now we can add different zones. So let's just add a rectangular zone. That's the DevRel Studio area, or it could be the toy store. And we can select that object and give it a name, give it a color, your choice. And then let's choose a polygonal zone. And I want to create an irregular shape. We're going to start about here and go to this beam, and then up here, over, and then click the right mouse button to finish the shape. So now we have a T shape. When someone comes in the front door, we might put a beacon to start there. They might go into the studio, and then they might come out and maybe go over into other departments. We can also place beacons on the map, either as they are in real life or where you're going to place them. So we'll click the Create Beacon button. And for example, we might put a beacon here at that location and place another beacon over at the far end, one at the turning point here, at the extremities, for example, another turning point there. And then for each of these beacons, we could give them a name. DevRel Studio, the DevRel area. Maybe this beacon here is for the DevRel doorway. We could put in the GUID for that beacon and the major and minor number. You could also specify a path. So a path, for example, might be where the person comes in and then goes into the DevRel area, maybe goes to the center here, goes in and walks into the studio, or maybe they continue from this point and go to the end. They might also go visit an office here, and we could set up a description for this node. This might be the example, enter the offices. You could use this information, for example, to display the user interface or send a message to someone who's in the offices that someone has arrived and or is moving towards the studio. If you want to show all the objects that you have and be able to select and edit them, you can go and click on each one, and you'll notice they're highlighted in the map for each of the paths, for example, and the nodes, the zones, the beacons that you've placed. So you can place them down and then go and set all of their object properties using this tree view. We want to set information about points of interest. For example, we could say, so this node, for example, might be the entrance to the RAD Studio. We can go and give it a name value pair or a set of description values. And then at runtime in your code, you can use those descriptions, key value pairs in your applications. Then we can save all of those changes. We'll put a button down in a toolbar, and we'll align the rest of the map to the rest of the client area. And then on the button, we can go and create an on-click handler, and we need to turn on beacon map fencing. And if we were using zone fencing, we'd have to enable that as well. We go back and make sure that we have all the options that we want. For the map options, do we want to color the beacons? Do we want to highlight any zones, show the current position? Maybe that's one of the things we want to do. Show zones, show paths on the map, and so on. It's your choice. You can color a beacon, which will display beacons of different colors based on proximity. So green for intermediate, near for yellow, far for orange. You can highlight zones, show zones, show paths, and then you've got for beacon fencing, got proximity events, for example, on beacon enter, on beacon exit that you might want to hook. On beacon proximity, it gets triggered every time the proximity value changes of the user who's running the app to the beacons in your map. There's also zone enter and exit events that are triggered when the calculated position is inside of one of your zones that you defined. There's also an API for computing the position. There is a default position calculator that's built in using the particle filter algorithm optimized for localization tasks. In particular, this particle filter corresponds to a Monte Carlo localization algorithm. There's also on calc position triggered when the position is calculated, estimating position when position is estimated, and triggered when the calculated position changes on position estimated. So you can hook all of these different events. And so there's the map that shows up, and I haven't hooked all the different events. First, it'll say, since it's beacon-based, you have got to give access to the location. And then we could put logic in, for example, to display the position and follow along as we are connected to the beacons from our smartphone or tablet app. And here's an example that ships with BeaconFence. It's another example that uses a map. In this case, it's a map of our offices in Spain. We're going to add the map to our project and then bring up the map editor and show that map. And some zones are defined plus locations of beacons like we saw in the map editor example. We've got some key value pairs set up for different nodes in the map for people's offices, as well as for some of the cubicles that are there. You can look at the different beacon values, make sure those are okay. If you make any changes, you can save those changes or forget about them. So we can choose platform iOS, Android, or OS X. Here we'll target a Nexus 9. And then it will install the APK file to the Nexus 9. And now we've got the application running. The black dot will show us where the current smartphone is. The application has some options in the toolbar for turning on and off the position information, the paths, the zones, and so on. So you can play around with those once you have the BeaconFence installed and you get some beacons and put them in your own locations. There's options in the sample for hooking into the calculations for proximity using the particle filter algorithm. Also, you can get a display of the beacon information, the list of beacons, the current positions, the major, minor, the distance, proximity, and so on. You can search for the different points of interest and then bring up information about those points of interest, displaying the key value pair data for each of those. And then as the smartphone moves around, you'll see the different zones firing, the little black dot, and the beacons that are found by the application in a proximity. And again, here we can look and see as the person enters a zone, the zone gets highlighted with a different color, and you can get information about what's nearby the current location, what the points of interest are, someone's office, maybe a meeting room that you're trying to find. So you saw in the demo there, when they were at the threshold between two different zones, then the information is displayed as you're transitioning, exiting one zone, entering another zone. And here you can see as the person who has the smartphone is wandering around the offices and seeing what's nearby for someone they may need to visit. At any point in time, you can build your application to show information about what beacons are within proximity. The application shows that it can load different maps with different zones and different beacons for different locations. So you could build that into your application for your customers. And you saw when I first started with the map, I set up the scale of the map by loading the bitmap in and then drawing a section that had a known length. And all maps that you have, whether it's a blueprint of a building or whatever, is going to have some kind of scale, 1 inch to 1 mile, whatever it might be. So it's important to scale the map properly. The map needs to be 1-to-1 aspect ratio. You could probably calculate yourself if you had some other relationship on the map, what you'd have to do. But as far as the BeaconFence technology and the mapping technology is you load your map in and you pick whatever area you measure down to inches, centimeters, or meters to set the scale. To help in the mapping and the calculation of where you are as you're moving through all these different beacons and zones, as you're following paths and so on, you can measure between two beacons, or in fact choose two beacons and measure the distance and precisely measure the distance physically in your space, and that will help the position detection to be very precise, down to the centimeter, down to the inch, for precise positioning that way. The other thing you'll want to do, and we talk about these in best practices, you'll want to calibrate your beacons before you place them, and there's tips for the different beacon manufacturers that tell you how to calibrate their beacons so that you're getting the correct relationship between the transmission power and the RSSI, or the relative signal strength indicator, so that that's accurate for each beacon. The other thing is that beacons are affected by different environmental things like humans walking by, metal and other kinds of objects in the structure that you might have. If it's inside of a building, we recommend that you put the beacons up on the ceiling, or in a raised ceiling area. That way humans walking by, because we're mostly made of water. I think it was Jim that told me first that humans have a lot of water, and the signals don't like to go very well through water. So, a crowded hallway in a big shopping mall, for example, might get affected. But if you put the beacons up above a little bit instead of down low or along the side, you'll want to put them up so they don't disappear, so people don't walk by and grab them. In Amsterdam, there's an effort that they're doing called the Beacon Mile, and they have a mile of beacons placed down the roadway in Amsterdam that takes you by the different museums and stores and shops and so on. So search on the internet for the Amsterdam Mile, the Amsterdam Beacon Mile, and you can find more about all of that as well. This is all really cool stuff. You can download it since T-Beacon is included in RAD Studio 10 Seattle, and you can go in to get it and download the free trial of BeaconFence. It lets you place 3 beacons in a space, I think it's 150 square meters, and that's the free level, so you can play and design and work with these. You don't need to have too many beacons around to do the kind of triangulation and the calculation. If you do have irregular zones or large size zones, you may want to put several beacons. For example, if it's a circular zone and it's really large, beacons, 70 meters out, depending on the environmental aspects, you might want to put a beacon in the center of a circular zone and maybe a couple beacons 2 or 3 beacons at some of the exterior perimeter parts of a circular zone. If it's rectangular, 3 beacons. If it's a T-shaped or polygonal shape, you might want to put a beacon at some of the corners. Anything else to add in the world of beacons, Al?
You talk about all the places where this is already happening. Did you mention any of those?
Well, I mentioned the Amsterdam Beacon Mile. There's stores that have them. There's a famous shopping district in London where they have beacons in the sort of arcade or walkway that's going on there.
I know by me, some of the high-end stores like Macy's, Lord & Taylor.
Lord & Taylor, Marriott. Hotels are starting to experiment with beacons so you can find your way to different ballrooms and different restaurants and so on. I think I need to schedule a vacation to the Hilton in Hawaii and bring beacons, put them around, and then build a beacon app for them. And then if they'll let me stay there for free, that might be pretty good. You saw in the demo, if you're, for example, going to provide applications for a wide range of customers, you could build one application that does it all, and then all it needs to do is load in different maps. You could provide a service of maps and beacons once you know how the beacons are laid out and the floor plan layout of the library or the Dave & Buster's arcade game store. All that gets stored in the XML file and the bitmap so that you can just load all of that in on demand at runtime. You don't have to build a separate application unless you have branding. Even that, you could bring the logos and branding in from external files. So, you could build one app and resell it to have everybody use it and then sell map packs, map and beacon packages, for example. Let's see, is there a way to do a live setup for beacons by taking a phone around location and specifying where it's at? You could build an app like that. We don't do that kind of thing, but there are many beacon detectors. We even ship a sample so that you can, as you're walking around, you can find beacons, and then you could build an app that would save the same parameters that we save with the beacon map component editor in the XML file. So you could do kind of a live walking around a mall, finding beacons, having an app that stores all of that data, the IDs and the location. You might look a little suspicious if you're measuring with a measuring tape distances between beacons that you found, but it's all doable. I did that here in the office. I had a measuring tape. Of course, they knew what I was doing. We had placed the beacons around, and I just got a measuring tape, and I was measuring the distances between beams and between cubes and between the beacons that I set out. So you could definitely build your own kind of live beacon spelunking app, and there are many of these beacon listeners that you can download for iOS and Android from the Google Play Store and App Store.
One thing about doing that is you would need to have a frame of reference, because if you're like inside a mall going around, your GPS is not going to work very well, which is why you use beacons indoors, because your GPS doesn't typically work as well.
It's also not as fine of a measurement. I mean, again, once you measure distances between physically placed beacons down to the centimeter, down to the inch, you get really good location tracking. There was the question about three-dimensional spaces like multi-floors or a big atrium inside of a hotel. For three-dimensional, the beacons broadcast in all directions, so there's no specific 3D for a beacon, except that, of course, you could have beacons. You'd have to kind of figure out if you have beacons that are 100 feet or 100 meters up, and then you had a beacon that was somewhere else. But right now, we're just tracking XY on a specific surface. Beacons don't transmit in a direction. I mean, they transmit in all directions.
Yeah, one thing about if it was multiple floors is if you're expecting the beacon signal to go through the floor, that's not going to work very well, because it's going to really impede how much signal goes through. So it doesn't transmit in directions, but anytime it's to pass through an object, it's going to dramatically reduce the effectiveness of the beacon. So probably your best bet would be to just look at what, for multiple floors, would be to look at if are you closer to the beacon on this floor? Okay, then you're probably on this floor. And if you're too far away that you're going to be on the beacon on the floor, then clearly we're not on that floor anymore. As far as being like an atrium, you could do that with beacons, because like you said, beacons aren't directional, but the beacon
signal strength is about the only thing you could sort of play with if you have known locations again. And then Chris had a question, what about places where you don't have site maps? You can create zones There's a zone where you just put beacons and you don't have to have a map. So you can create a zone, and there's a zone component versus a map component. So investigate, download the BeaconFence. It's right from Get It, so you just grab it and look at the zone-based setup versus a map-based setup. So you can create zones as kind of arbitrary areas that have beacons with beacon locations. So there's two components, one for map fence and one for a zone fence.